the power of scientific ideas, the analysis of data, scientific breakthroughs, understanding nature and the study of human needs. Here, the ideas of the East are supported by Western technology. Here, collaboration between the greatest minds creates new solutions. Here, each discovery makes our lives easier and our environment cleaner and safer. The International Science and Technology Center is a platform for scientific collaboration and the promotion of science. This film will show the results of ISTC's work in Bishkek, the capital of the Kyrgyz Republic. After the collapse of the Soviet Union, when the Iron Curtain was drawn back, scholars in post-Soviet countries became free. However, at the same time, investment into science collapsed. The Kyrgyz Republic, with its great scientific potential, was one of these countries. Saving science in this new reality became a critical mission for the Kyrgyz people. The revolutionary changes that occurred in the 1990s created many problems for science, such as a dramatic decrease in funding, the decline of the scientists' social status, and a low demand for research from the economy. When the Kyrgyz Republic was part of the Soviet Union, its budget was subsidized as much as 50%. This financial support from Moscow had a positive impact on scientific development in Soviet Kyrgyzstan. However, when the country became independent, it suffered from a high degree of corruption, a sharp stratification of incomes, criminalization, and two chaotic revolutions in 2005 and 2010. The unseating of two leaders in 5 years left the country in a state of economic and political crisis. There was no way to do science in these economic conditions. In 1995, the International Science and Technology Center began to finance the Kyrgyz Republic's scientific projects and provide support to scientists. Since then, it has become one of the most important science donor agencies in the region.
After the collapse of Soviet Union, science was not among the priorities of new Kyrgyz Republic. Funding was cut back. The huge inflation turned to nothing the salaries of scientists, and many of them were forced to look for a second job. The uncertain economic future of the region still makes it impossible to support science. There is always the question of quality versus quantity. Official statistics regarding the number of scientists who have emigrated to other countries are very limited at present. Moreover, many scientists have gone abroad under temporary arrangements that enable them to stay at the forefront of research. How many will return is uncertain.
Like most post-Soviet countries, we were going through hard times, and any financial help is still critical for us. There was no way to do science in this economic situation. We highly appreciate the project selection by ISTC and the funds, which keep driving our science through the hardest time. The financial help we received literally helps science to survive. The agreement establishing the ISTC stipulates that the center's principal activity is to develop, approve, finance, and monitor science and technology projects for peaceful purposes, which are to be carried out in institutions and facilities located in Kyrgyz Republic. Thanks to the assistance of the ISTC, all participating institutions have significantly strengthened their scientific and logistical base. Moreover, all equipment on the basis of 2 decrees of the government of the Kyrgyz Republic was transferred to the balance of the implementing institutes. Kyrgyz scientists started traveling to international seminars, conferences, symposiums with the financial support of the ISTC.
The significant number of their best people had left for non-technical commercial jobs in the Kyrgyz Republic. This internal migration, which has involved disproportionate numbers of younger scientists, who are more mobile than older scientists and who may have more opportunities in non-scientific careers, has been more deleterious to the Kyrgyz science community than emigration abroad. As a result, the institute's staffs are aging. Several institute directors commented that the average age of their scientific staffs is now over 50. As there is still no room for growth and no financial incentives, the ISTC hasn't managed to reverse this trend entirely, but has had a positive impact.
We consider our science as one of the oldest in the world. Most of the graduate students had left science due to the lack of funding. The reasons are low wages, the absence of material base for research and development, bureaucratization of the organization of scientific work, and the low prestige of scientific work. The funding we get from international organizations such as ISTC helps us to do some science work, but it's not enough to keep young people from leaving science. The government funding covers mostly the salaries of scientists, but they don't get any money from budget to run the projects.
In many disciplines, our old professors have been left without apprentices, and our young scientists have no one to learn from. These gaps should be filled not by restricting the mobility of scientists, but by expanding it, and not only by encouraging our scientists to return, but also by attracting leading foreign specialists to Kyrgyz Republic.
The Institute of Physics has not been renovated for a long time. Most experiments are still carried out on Soviet equipment. The only money the Institute gets are via projects funded by ISTC. It helps to buy new experimental facilities. However, there is still not enough funding to engage young scientists to work in the Institute.
Kyrgyz scientists, young and experienced, not motivated to work in science projects. The main reason is small and unstable income. They also get fewer opportunities to travel, publish their papers, and carry out experiments in fully equipped laboratories. Of course, ISTC helps financially, but it's not enough to cover all science needs in Kyrgyz Republic.
Valentina Alekhina has been working in the Institute of Physics for almost 40 years. Her team is working on a project related to thorium transport with natural water. She says that measuring the migration of thorium to rivers of the Kyrgyz Republic is very important. She hopes that one day more young scientists will be able to join the project.
In 1964, at former Aktus mining enterprise of Kyrgyz Mining Metallurgical Industrial Complex, and at Kyrgyz Chemical and Metallurgical Works, an accident took place. The dam was destructed and sand with high thorium concentration got in rivers Kechekemin and Chu. The researches of soil nearby the Chu River and territory of Kazakhstan made in 2002 showed increased content of thorium, its decay products and other toxins, characteristic for rare earth production. Accumulating industrial sewage tanks of Kyrgyz Chemical and Metallurgical Works, as well as other enterprises of radioactive raw materials, processing located near the river Chu, are also potentially hazardous. The main goal of the project is the assessment of man-caused thorium and radium contribution in radiation background, as location of rare earth raw materials, mining and processing in Kyrgyzstan, and the assessment of their influence on human and biota.
All participants of the project are experienced in carrying out radiation, hydroecological, and isotope chemical researches. Our team includes leading experts in the field of filtration, water, and air mass transport numerical modeling. We want to assess radio-ecological and toxic hazard and give consequent recommendations for preventing negative aftermaths from chemical technologies' impact. Our collaborators leading US universities help us to analyze the data and monitor radio-ecological and toxic hazard mitigation. Without these partners, it would be almost impossible to carry out this project. The study of radionuclide and metals concentrations in the rivers of Kyrgyz Republic is of particular interest in the region because of the history of nuclear materials mining, fabrication, transport, storage, and nuclear weapons testing during the regime of the Soviet Union. This industry left a legacy of radionuclide and metals contamination in some regions, which poses a health hazard to populations who rely heavily upon surface water for agricultural irrigation and direct domestic consumption. Therefore, monitoring for radionuclides and metals in rivers can be an effective tool both for helping safeguard public health and for creating transparency, building confidence, and supporting non-proliferation treaties.
Science that benefits society is all about understanding and solving what we do not yet know. But there are still many obstacles. They include the archaic system by which Kyrgyz science is organized, in which scientific research is often artificially separated from education. Kyrgyz science has long been isolated from global science, and as a result, our scientific priorities and support systems are obsolete. Science is notorious for its paternalistic nature generally, and in our case, it has been further exacerbated by its Soviet heritage.
The current situation is fundamentally different from what it was in the 90s. It would be premature to speak about the breakthrough, but positive changes are obvious. The nature of modern science is global, and it would be wrong and detrimental to impede the international mobility of scientists, for a number of reasons. However, this mobility has proven to be one-way street for Kyrgyz Republic. ISTC implements large-scale projects with a relatively high success rate, and funding for the project is relatively big and allows the purchase of modern equipment and all necessary materials. Also, projects require international partnership, creating a collaborative environment between researchers from the CIS and renowned scientific groups worldwide.
Global problems need global solutions provided by a global team. Therefore, ISTC dedicates significant efforts to the internalization of the research by providing travel opportunities and organizing conferences and workshops. One of the biggest global challenges is climatic change. Collaboration within ISTC stimulates the sharing of scientific knowledge and best practices for measuring pollution in Central Asia, supports pilot initiatives, and helps with academic input when necessary.
At the current time in the Central Asia, microphysical and optical properties of submicronic and coarse aerosol fractions are studied in detail enough. As to microdisperse fraction, nanoaerosol, formed from gas phase and defining start-to-all aerosol process, data on its behavior in atmosphere are incomplete and rather inconsistent owing to what it is impossible to make a full picture about contribution of aerosol to atmospheric processes. The purpose of the project is research of influence of microscale aerosol on radiation transfer for estimation of climatic changes in the Central Asia. Participation in the project will allow this scientist group to use scientific ideas, technical development and experience received at realization of works in military area for developing of peace technology directed on formation of environment monitoring system and effective using of natural resources. The LIDAR station Teploklychenko is a unique site in Central Asia where atmospheric aerosol measurements are obtained using a multi-wavelength laser system, LIDAR. This location in eastern Kyrgyzstan is in close proximity to the largest sources of dust in Central Asia, for example, Aral Sea Basin, Taklamakan Desert, and SE China's atmospheric brown cloud. Measurements at LIDAR can help better understand pollution transport to and within Central Asia and their influence on the ecology of the region. Due to the lack of extensive data on aerosol vertical profiles, there are large uncertainties in forecasting atmospheric radiative forcing due to differences in the vertical profiles of the atmospheric aerosol as applied in models. The ability to retrieve information on the spatial structure of aerosols by ground-based remote multi-wavelength laser sensing allows for not only the identification of particle layers aloft, but also the ability to study transport processes and to lower uncertainty in estimates of radiative forcing that are sensitive to the vertical distribution of aerosols. Therefore, in recent years, LIDAR measurements are widely used for studying the spatial and temporal variability of aerosol properties, in particular during Asian and Near Eastern dust events. The results showed that regional sources are characterized by transport of pollution with maximum coarse particle mass concentration. An increase in dust storms was observed during the transition from the cold to warm periods, which resulted in a higher fraction of coarse dust particles that affected the aerosol layer thickness and optical and microphysical characteristics of atmosphere. The science group includes experts in optical methods of research of physical and optical properties of atmospheric aerosol and statistical regularities in processes of distribution of aerosol pollution. Our collaborators from USA, France and Germany became our most valuable partners, and we continue this mutually beneficial cooperation even after projects are completed. Kyrgyz scientists were able to present the results of their work to the international community, which contributed to a significant increase in the level of scientific research conducted in the country. Employees of many institutes passed training in leading scientific institutes of the world on development of new methods and exchanged scientific experience with foreign colleagues. Participants in ISTC projects have made hundreds of business trips to participate in international scientific conferences and exhibitions. The teams of institutes participating in ISTC projects have replenished at the expense of young specialists who are able to conduct scientific research at a worthy level. To date, the Republic has carried out 5 ISTC scientific projects for about $2 million. Further, ISTC activities in our region, characteristic as a geopolitical crossroads, will continue to make a significant contribution to ensuring sustainable development and the necessary stability of the entire world community.
ISTC has become a part of life for Kyrgyz scientists. Every day they come to work and try to find new solutions, new ways of thinking to move science forward at least one small step. It is how it should be and how it is.